All right, so I'm going to look at this example and try and come up with the volume of the object whose cross sections perpendicular to the x-axis are isosceles triangles. Well, I think what I'll do before that is I'll do an example where instead of this being isosceles triangles, I'll make it be squares just because they're usually easier. And then I'll do it again, and I'll do it with isosceles triangles. All right, so basically this area down here, you see, you have your y equals x squared, and you have the line up top here, which is just the line y equals 1. So if I was to take and draw one of these cross sections, this is what they would look like. So imagine that this is the bottom. I'll go right here, and you get a line. That's a bad line, but it's a line. And then coming up out of the page, you would get a square shape. So I'm trying to look something like this, where the length of this side and the length of this would be the same. And everywhere you drew that, that would be the case. So if you drew a small little one, let's say right here, it would still be shaped like a square. So that would be the same as that. Well, the length of this side, kind of use our whole upper minus lower notation. So the upper is just the line 1, and the lower, the y value here is just x squared. So that would make the distance from here down to here be 1 minus x squared. So if I'm trying to get the volume of this object, it's the sum of the areas of the cross sections. And every cross section in this case is, so if it's a square, the area of a square is just the length times the width, and they're both the same. So the length and the width are the same. So I would go integral. So the length times the width would be 1 minus x squared times 1 minus x squared. So I'm just going to put squared. And then the thickness of each one of these little cross sections would be dx. Now, this point right up here on our graph, that would be the ordered pair 1, comma 1. Now you say, well, how do I know that? Because if I fill 1 in here, that will give me the y value. So that's going to be the ordered pair 1, comma 1. So basically, we're going to start the cross sections at 0, stack them side by side until we get to 1. So there's your bounds for your integral. They're going to be 0 to 1. And then basically, I would just 0 to 1. Oops, get something there that I shouldn't have. Undo that. So it'll be 0 to 1. I'm not going to do it all out, but you'd expand that. So you get 1 minus 2x squared plus x to the 4th dx. Take the antiderivative of each one. Maybe we'll just do it to refresh your memories, I guess. So 1 minus twice x squared plus x to the 4th. We'd have our dx here, which would be x minus 2/3 x cubed plus x to the 5th over 5 after you do your antiderivative. And then your bounds would be 0 to 1. Fill in your upper bound, you're going to get 1 minus 2/3 plus 1/5 minus your lower bound, which would be, it's going to be zeros everywhere. So you just figure that out, and that will be your volume of the object. So that's how you do it if it was squares. So basically, it's the same thing every time. It's just a matter of what shape this object here is going to be will dictate what formula you're going to use to get this area. So that one was a square, so I just went length times width. Now this one said that they were isosceles triangles. So I'm just going to clear everything I've got here and start over. Okay, so if it was isosceles triangles, so I'm going to kind of start the same way. I'm going to draw one of these triangles just so you can see it. That's going to come down. What does it say here? Isosceles triangles with the height equal to the base. So that would mean then this is the base. So coming out of the page towards us would be this piece, which is going to be the same. So I should go a little further. It's the same length as this. The height and the base are the same. Like that. Which means that this is going to have to be a right angle. Didn't really say that in the question, but for the sake of doing the question, let's assume that that's what they meant. So now, because the shape is a triangle, well, to get the area of this cross section, this is still going to be the same thing. The distance from here down to here, like in the last one, is going to be the upper, which is 1. The lower, the y value on the lower down here is x squared. So this length here is 1 minus x squared. This length up here is the same, so it's also 1 minus x squared. So you've basically got a triangle that looks like this. Crossed here. This is just one of the cross sections, which would be 1 minus x squared. 1 minus x squared. There's a right angle here. Well, if I wanted the area of that triangle, it's half the base times the height, which is the same thing. So it would be that. So the integral, if I change it to right triangles, like I'm doing right isosceles triangles here, would be this. 0 to 1. So I've got this half. I'm just going to put that out front. It's a constant. 1 minus x squared squared dx. Well, the nice thing about it is, if you notice this integral right here, 0 to 1, 1 minus x squared squared dx, the exact same question that I just did. So once you had the answer for that one, basically all you'd have to do is go a half. So if you had already done the square part, you would take your answer you got when you did it as squares, and you basically take half of it. So it'd be half times whatever that answer you got from the last example was, and that will give you your area. Anyway, I'll stop here and let you have a look at this and see if this helps.